Dear students and participants on the course on railway engineering, today we are going to continue our discussion on the interlocking systems. In the previous lecture, we talked about two main systems which have been in use. One is the key interlocking system, another is the mechanical interlocking system. There are other systems also which are available for the interlocking purposes, and we are going to discuss about those types of interlocking systems today. We will be talking about the electrical interlocking, the panel interlocking and the route relay interlocking systems. And within the RRI system, the British system and the Siemens system which are available, which are in use, we will be discussing about the salient features of that. Starting with the electrical interlocking system, on the right hand side if you see, there is a photograph wherein a track is going to be set. So, we have this is a tongue rail. So, the tongue rail is going to be moved based on some impulse or energy which is being given through the connectivities here, but there is no such lever being used at this point. So, some electrical circuit systems are there, and with the help of that all of the things are going to be set. So, what is this? That is what we are trying to look at. Now, with modernization of the Indian railway network, electrical signaling and interlocking system is replacing the mechanical signaling and interlocking system. The reasons being, the mechanical system has large number of movable parts, and because of so many parts there is always a possibility of something wrong happening. The wear and tear may be there may be a failure, there may be losses because so many connectivities are there. So, one is attached to the another one. So, when you operate them, so some certain losses can be there. So, those frictional losses, if it is there, can affect the system, or some of the parts are such that somebody can take them out also. So, there is a possibility of a sabotage. So, this is one of the reasons why it is better to move from the mechanical system to the electrical system. Another, the semaphore arms have low visibility during the day, and the light system is also often not a good quality during the night. And operational time of mechanical systems is a bit longer as compared to these electrical systems, and then afterwards when we talk about route relay systems and finally the electronic system, the things further goes down. So, in the more advanced electrical or electronic interlocking systems, the points and signals, they are worked from one integrated mechanism in a signal cabin. So, there is only one such integrated system from where you are going to operate the things. It features a display of the entire track. So, whatever the track is available, say the track is in this form or in this form, or again it may happen that the track is further being divided. So, or from here it goes in this direction. So, whatever the type of track is available, that is being displayed, and this particular layout had certain indications. Now, what indications we may talk? We may talk about the indications of the points or the crossings. We talk about the indications where the signals are being provided at different points. Say, if you talk about the station condition, we discussed about the signals like outer signal, home signal, starter signal, advanced starter signals. We talked about the stop signals, warner signals, distant signals, or some specific type of the subsidiary signals were also discussed. So, wherever any such thing is there, that is going to be depicted by some indication on this panel. So, the sections that are occupied means the train is moving on that particular section. So, that is also being indicated there. If it is free or it is going to be set for the reception or the dispatch of a train. So, everything is going to be visible on these type of systems. This interlocking is accomplished not by mechanical devices, but by electrical circuitry like relays and switches. In older electrical or electro-pneumatic system, and in the case of newer systems, it is a computer based circuitry system. So, now the things are relatively more easier to operate. But when you are operating the whole of the system from one particular location, you need to take care of many things. So, here it is being shown that this is an electrical locking of points and the signal levers. So, there can be the point levers or the signal levers. Within the point levers, it is track locking or indication locking, and within this track locking or this indication locking, it can be the normal to reverse or reverse to normal conditions, means in which particular direction the locking systems are going to be worked. Similarly, in the case of the signal levers, it is reverse to normal with indication locking, approach locking and the back locking. So, the approach, that particular area, all these locking systems. So, these are the part of this electrical locking system or interlocking system. Similarly, in the case of route release, there are two things. One is the route release by train movement, another is the signal lever pulled back to normal. So, it is a B lock system, then signal on condition, then the movement cancelled, whereas approach tracks are free, approach tracks are not free or not provided, or there is a immediate release of a route or release of route with some delay. In the case of the route released by the train movement, what happens is the train, when passes the signal comes at on. Now, it says that this particular section is being occupied, then the sequential operations will be there of the different signal systems, then backlock train circuits becomes clear, levers are pulled back to normal and the route is released automatically. So, the things are happening, many of the things they are happening automatically, but there are certain switches, certain buttons which needs to be operated in the control cabin. From on the basis of that, these release things will be there or the setting of the things will happen. So, the first one here we are talking about a panel interlocking. A panel interlocking system is the one which is used in most medium sized stations on Indian railways. In this, the points and signals are operated electrically from a central location and the switches which control them are mounted on a panel. So, one such diagram is being shown here on the right hand side, where the track is being shown, and on this particular track there are different locations where certain indicators are there. So, those indicators will define that the train is here or what is being set or what is not being set. You can see that some of those are in white color, say this is a white color, this is also a white color, some are not depicting any color. So, based on these color combinations, it will give an idea that what is being occupied or what is being free, what is being set or what is not being set. Each point on a route is set individually with the switch and the clearance of the signal is obtained by operating the signal switch. The interlocking of these is achieved through the relays. All the operations are controlled centrally. The time which used to get lost due to coordination between multiple cabins is saved in this particular process, because previously we were working with north cabin, south cabin and those. Now, we are doing everything with the help of this panel display system which is provided in the station master's cabin. This is also known as non-route setting type interlocking. The panel is provided with illuminated indications, as I said, for signals, points, track circuits, crank handles, the level crossing gates, sidings, etc. And all of these things, they are being shown with respect to their geographical location. So, if it is being shown here, usually it is known that what is the distance here. So, we can identify that at what particular distance from this point this indication is coming, which is for a particular stop signal or setting of a route or whatever type of condition is there on that particular track. So, what is the process here? To take off a signal for a particular line, either for a through train or for a stopping train, all the points in the route in overlap and in isolation are to be set first individually by turning the required point knob and switches to the required position. So, the first thing is that you have to identify what is the length, and that particular length, how many signals are going to be there and how many points are also going to be there. Then on the basis of that, whatever points which are coming on that road or overlap areas or the isolation overlap areas, we will be discussing certain things related to that when we take up the train control system. So, these definitions will be taken up there. But this overlap can be the block overlap, it can be a signal overlap. So, in that overlap area also, as well as where the isolation is being done. All of these going to be set individually one by one. So, for setting that, then there are certain knobs and those knobs are going to be operated, and as soon as you operate those knobs, then that setting will happen and it will be shown on this panel. Now, once the points are being set, then the signal knob S is to be turned to the reverse. So, the two systems are there in this case. On reversing the signal knob, the route checking relay UCR picks up after checking the route and drops approach stick relay ASR. Now, this UCR, ASR, these are all circuits which are provided on the overall track. Number of types of circuits are there and they are going to be operated. So, one gets pick up, another gets drop in. So, that arrangement is there when you are operating these switches, or you are putting your the pressure on the knobs which are going to operate the points of the signals. The signal control relay HR picks up and the signal is taken to off position. Then route indicators for the set route will appear as white illuminated indications along the length of the panel. So, here if you see that along the length of a panel, this white indicators are coming up, that means this is being set. As and when the train passes the signal, travels over the route, the illumination first changes to red when the track is being occupied, and then it changes to white when the track is being cleared, that is the train has moved in the next section. So, incidentally in this one the no red color is being shown. So, say if the train has moved in this area, so this one which was white will convert into red. So, it indicates now this particular section is being occupied by a train. Now, as soon as the train moves from here to another section, then this one will turn back to white. Now, that means this is not being occupied, but there is a train just in the ahead block. So, it is also given indication to the loco pilot of a train which is coming at the back side, that still there is a train which is moving in front at some distance. But as soon as it is going to move further, say this moves from here to another block, then this indication will get switched off, that means it will indicate that now it is free. As and when, so that is what we said, the train passes the signal, the illumination first changes to red, that shows the occupation of the track, and then it goes to white, and finally it goes off when the train cleared entire route and the signal switch is normalized. Now, the another one is a route relay interlocking. Route relay interlocking is a further improvement on the panel interlocking. More or less the procedure is going to remain the same, not much difference is there. You can see again in this photograph there is a big route along with the various combinations of the loop lines, branch lines or the station area. They have been shown, and there are some which are in red color, some in green color. So, the distinctions are also there along with the various points which are being illuminated. This system is used in the large and the busy stations which handles the high volume of train movements. In this, the entire route through the station can be selected, and all the associated points and signals along the route can be set at once by a switch for receiving, holding, blocking or dispatching of the trains. So, all the works which are required, you have to receive the train, then the train has to be dispatched, and in this particular period one of the section has got blocked, or the previous section is going to be hold, so that no train moves into that, because you have to maintain a certain gap between the movement of the two trains on the same track in same direction. So, this is being done all by a movement or by an operation of a switch. Now, this process uses a pair of switches to automatically set the route for the train by putting all the points along the route in their designed positions. And while doing this, it should be ensured that no conflicting movements of the trains is under progress and the route is clear for the movement of the train, including at the overlap area. So, whenever something is being done, whenever this decision is being taken by a person and the person operates the panel, they have to ensure that no conflicting movements are going to be there. At the same time, when the train is going to move in a particular area, there are not going to be any obstructions to that. It necessitates to track circuit the entire yard also. In this particular case, because the trains are going to come from the yard, there is going to be a shunting. So, the yard also is going to be track circuited. So, here also, as you can see, a big section has been shown. So, it means it is an station area where not many lines are there along with the lines which may be going to the yards. Once the route is set for the passage of the train, the relevant portion of the diagram on the panel gets illuminated with the white lights. Again, the notations are going to be the same as we just discussed previously. So, white lights are being used as soon as the section is being occupied. The track turns red when the train occupies there. It has already come. So, first of all, you have said that you allowed the train to move in. Once the train moves in, it becomes red, and as soon as the train clears, the track lights automatically gets off. Now, it says now this particular section is free for receiving the other trains. So, what are the merits here? The first of all, we are looking at a British system of the route relay interlocking. So, it is a quick and efficient operation. It is easy in installation and maintenance. There are no overhauling procedures. It is suitable for all types of yards. It is having less detention to the traffic, means the delays which may get caused because of the taking decisions, taking the information about the route, about the various blocks either at back or in advance. So, that time is being saved because you are looking at each and everything on the panel which is available in front of you if you are the operator of the system. It is suitable for the RE and non-RE type. So, it is a route or non-route conditions. Then long range of operation, increase in section capacity because you are taking the decisions fast, you are trying to utilize the tracks as fast as possible. So, the section capacity is also being utilized to the maximum value. And there is a less operating staff, and when there is a less operating staff, then the possibility of the errors which can be committed at different levels reduces. But it has some demerits too. The initial installation cost is comparatively high. Reliable and stable power supply is required so as to operate this type of a system, and efficient and high quality maintenance is also required in this particular system. So, this reliable and stable power supply, if it is not there, everything goes to off condition, then there is no clue what is happening. So, all of the system will come to a standstill condition, because in that case everything will go to the danger condition and the signals will come to the on condition. Here a comparison is being given for a panel interlocking and a route relay interlocking. The panel interlocking, the non-route type of setting, it is a route type of a setting. In the case of panel, the route is set by setting the points individually and then signals are taken off. Here, the setting of routes and taking of the signals is being done by pressing the route buttons concerned and by pressing the signal buttons or turning the signal switches in the reverse direction. The panel interlocking can be used for smaller yards or the wayside stations, whereas the route relay interlocking can be used for the bigger or the major yards. Then CLS is operational, that means the color light signaling system, that is operational, but in the case of route relay it is a compulsory system. Here we are not working with the semaphore system. Then route buttons, they are not compulsory because we are already working with the individual capacity with all those things, but here the route buttons are compulsory for the RRI system. Sectional route release is not provided normally, but here the sectional route release is provided for better flexibility. Track circuits on axle counters, they are provided between home to home signals. Here they are provided between the outermost signals. We will be talking about these track circuits and axle counters later. Then point knobs are of two position, that is N R if the knobs are provided. Then in the other case of a RRI system it has three positions N, C and R. So, it's a normal, reverse and the central condition will be there. Emergency point operation is not compulsory in the case of a PI system, where in the case of RRI system this emergency point operation is compulsory. Now, let us look at the control panel for this RRI and discuss about few things here. All signals are provided with the rotary type switches. So, you can see here the rotary type switches. This is a two position system and an R system. At this one it is being set to the normal condition. So, if you move it here, then you can set it to the reverse condition also. These switches and buttons, they are nearer to their geographical locations and being provided with the indicators on the control panel. All points are provided with two position or three position switches for PI and RRI respectively, with indications for normal as yellow, reverse green, logged red and free as white. These are the color indications, codes will be coming. The track circuits are provided as per yard, demarcations are provided with different colors and occupied and field indication is given in the red color. Then controls for sidings, level crossings, crank handles, they are provided again with the buttons or switches, and alongside that there are indications which are provided. So, you can see the buttons and switch condition and indications are being shown here. When the route is set and locked, the white strip light indications will appear on the route. So, whatever the route is being set, so if this is being set, then this white strip will come on this one and will be extinguished on arrival of the train or cancellation. So, it will switch off. Controls for emergency signals and the route cancellation, emergency point operations with controls, they are provided. We already discussed in the case of the comparison between PI and RRI. Then station master's key will be provided to lock the panel to prevent any unauthorized operation. Nobody else can do anything other than the station master. There are some indications which are on control panel. So, if it is a track clear, no indication will appear. Track clear, route set and locked. So, you have set the routes, it is being locked. As soon as it is being done, it is white, but still the train is not there, the train is going to approach. As soon as the train comes and occupies, or even if there is a failure, then it will go into a red color. Then the point indications near the point knob and the switches, normal and locked yellow, reverse and locked green, then the locked in the route is red and the points are free, that means yellow or white. So, this is how the indications will appear on your control panel and you can understand that what is happening. Then if the siding points are there, they are normal and the key is being put in, then it is yellow, but if the key is out, there is no light being shown, it means it is available. Another method is instead of these type of light systems which are being provided as an indicator at that location itself, the another way is that we have a strip of the light. As we discussed previously, we said the whole of the track is going to be lit with the white strip. So, that is also another system. In the case of signal indications, signal is like a stop signal is on, then that is red. We have already talked about this when we discussed about the signals. An off condition, It can be green, it can be yellow, or it can be double yellow depending on whether it is a Warner or a distant signal respectively. The route is on, no indication. If the route is off, then it is a white strip. Then further, if it is a permissive signal, distant signals are used in that. If so, it can be on or can off condition. Again, if it is on, it is yellow because it is giving you a cautionary condition that the train can be moved. But if it is an off, it is green or double yellow. And we have discussed that what is the meaning of yellow and double yellow in terms of how the train is to be moved on the section. Then for shunt signals, now if they are being provided separately or if they are being provided with the stop signal, that means on the same post, again the conditions will remain the same. That means either it is an off condition or an on condition. So if it is an on condition, two white lights horizontal, we discussed about this if you remember that there was a block in which the lights were shown in this form. So if these two lights they are being lit, that is what it says. Two white lights horizontal means it is an on, and off is, that means this two inclined or diagonal lights, if they are on, that means it is an off situation. Then in the case if they are being provided with the stop signals, so in on condition there is no requirement, no indication may be there, but if it is a off situation is there, then the two white lights diagonal will be coming. So it means now it is on this post, and where at the top the stop signal is being provided. So in that case only this is going to be lit, this will not be lit. Then calling on signals, again they can be there on this particular post itself at the bottom of the stop signal with the C inscribed on the disc. So when it is on, that is no indication, and there is another case which can be there is a miniature yellow, maybe one case. Crank handles, in the case of crank handles it is in, out or free condition defined by the green, red and white. For the level crossing, open and the close, red or yellow green. The slots, we talked about the slotting of the route and the tracks or the signals. So there if it is granted, yellow. If there is a power ACK failure, whenever it is a failure it goes to red. But in the case of signal lamp failure it is yellow, point indicator failure it is yellow, and button is stuck up, then it is yellow. It means the caution is being defined, because in the case of CLS system it says that the green is already there always, so that the train can come in unless and until there is an obstruction or a failure or some other aspect is there for which a red is to be shown. Now as we said that there are other type of RRIs which are the Siemens RRI, which are based on metal to metal relays. Now in this the pressing signal and route buttons, route will set and point will be operated to required position, point will be locked, route will be locked and signal will be cleared. So all of the things again they are going to happen on the with the help of the pressing of the various buttons. After the passage of the train, the route will be unlocked, point will be unlocked, and then the point can be operated to other position. So that's again will happen using the relays. Conflicting signal movements cannot be initiated before the completion of the previous signalized move. So it already some authority is being given for the movement. So now you cannot operate a signal which is going to create a conflicting movement, in that sense that the train now can come on the same track. The points can be operated independently, and in case the point is not operating after the route is being set. After the clearance of a signal, the station master can cancel the signal route, including overlap with some time lags. Overlap can also be cancelled by the station master if it is required with time lag. Now route can be cancelled by station master with the cooperation of the signal and telecommunication staff. That means the station master has to communicate with them, and then on the basis of that cancellation can be generated. Now, here there are different types: the signal group for signal clearance, the shunt signal group for the shunt signal clearances, route group to operate and log the points and giving the indications accordingly. Then the point group, this is for operation of the points and giving indications. Point chain group, that means the sequential one, the sequential locking system which we discussed previously, the same is being talked here. Interlocked relay to retain in the last operated position. Then neutral relay, lamp proving relay, time relay, the flasher relays, all of different things are there. Then there are buttons on the control and indication panels which are used for specific conditions. They have the codes. Using that particular code, that thing can be set and operated. Here like EWZ, this is for emergency point operation counter. Then EWYZ is emergency route cancellation counter. EUYZ is emergency subroute cancellation counter. COOGZ, this is calling on signal clearance counter. OYZ is emergency overlap cancellation counter. Now, what are the sequences of the relay operations which are used in this metal to metal relays provided by Siemens is, first of all, the route and signal initiation circuits will be operated. Then subroute overlap settings and locking circuits are going to be operated. Then points control, detection and locking circuits. Then signal clearance circuits will get operated. Then route release circuits which will get operated. These automatic and manual cancellation circuits are there in these particular type of circuits. And then finally emergency subroute cancellation circuits are also there. We just looked at some of those emergency route cancellation circuits. So there are different type of circuits which will be available on the track, and depending on what is going to be operated in what particular sequence they are going to be operated, the operations will be conducted in the control room. Now, in the case of this major point relay group, it consists of 5 interlocked relays, 13 neutral relays, 1 contractor relay and the 3 lamp indicators. Now, there are certain codings. Z1WR, this is the first relay to operate point in the route or overlap or isolation. There is Z1WR1, this is the first relay in individual operation of the points and the third relay to operate under the route initiation. WLR, it is the second relay to operate a point during route initiation. So, these are different type of relays. So, depending on where the train is, what is to be operated needs to be controlled from the control panel. So, again Z1 NWR or RWR, so it is one for a normal condition, another is for a reverse condition. So, that is an N and that R, that is how they are being used. So, this is a pickup and hold relay. WKR1 is a point detection relay. WR or NR, again that is for the reverse and the normal conditions, facilitates superimposed detection during the group initiation. Then R oblique N WLR with 3 conditions as 1, 2 and 3. So, there are 3 different type of latch relays which help in the registering the operation command. Then WR or N LR, this is a point group lock relay. WKR2, this indicates out of correspondence of the points and the point relay groups. Then WJR, this is a overload protection relay. Then ZWR with the 2-1 and 2-2 conditions, these are the relays which give point strip indication on the panel. So, you will get continuously points which are being set. Then TP1R, TP1, P2R, these are related with the repeating of the point zone track relays. WKR3, it relay proves the end of operation of the points. WR is a heavy duty contractor relays. So, different type of relay systems which are available, they are being coded and accordingly they are operated. Now, the another type of interlocking, solid state interlocking, and this is the further development about the electrical electromechanical interlocking systems. It is a microprocessor based system, it occupies considerably less space, consumes less power, it is reliable, and it is easy to install and maintain. So, this solid state interlocking further goes into the electronic interlocking system, and that uh, it's being shown here on the track, which, as you can see, the very small space is being used. So, with this we are closing our discussion now. We will be continuing our discussion on interlocking and specifically electronic interlocking in the next lecture. Today we talk about the electromechanical and electrical interlocking. We have looked at the various panel interlockings or route relay interlocking systems, wherein the two type of systems were available from British and the Siemens. And we have looked at the various silent features, the indications which are can be provided for various type of operations. Thank you. We will be meeting in the next lecture. Till then, bye.